So let's have a look at operator overloading. Now, we're probably most familiar with overloading in the context of methods. When we have an overloaded method, it has the same name as another method, but it will contain a different parameter list. That might be a different number of parameters or a different type for the parameter. So we can apply that concept of overloading to operators as well. Probably the one which we're most familiar with is the plus sign. The plus sign can be used to add two numbers, or it can be used to add two strings together. So therefore the behavior of the plus sign depends upon the context in which it's used. And remember, this is the concept of polymorphism, the object-oriented principle, which applies both to methods and now we're going to apply it to operators as well. And there tends to be a difference in how unary operators are overloaded, such as the increment operator, which is plus, in contrast to binary operators, such as the plus sign, because remember the plus sign needs both a left value and a right value. We say if we want to add 5 and 7, 5 sits on the left-hand side of the operator, and 7 sits on the right-hand side of the operator. There's a left value and a right value. In contrast to unary, where there is either a left value or a right value. So let's start by looking at how we overload a unary operator. And to do so, we're going to need to create a method. As you can see here, we've got the method signature, which rather than the method name, we actually have the keyword operator, followed immediately by the symbol, the operator itself, that we want to overload. In this example, we're using the @ sign, which is then followed by a parameter. And this parameter is going to be a reference to a particular data type or an object which accompanies the operator. And it's based upon this reference that the compiler will know whether to call this method, the overloaded method, or the methods that have already been defined and would usually be applied with this operator. If the @ sign is accompanied by a string, referring to an email address, this is the typical implementation. However, if we use the @ sign with a number, the compiler would then look for a overloaded method which works with numbers rather than strings. So in this example, we're going to be overloading the exclamation mark to reverse the coordinates of a vector. In the main, you can see that we've defined v1 as a vector, which has two coordinates, positive 10 and 15, and then we output them with a cout statement, but then we call the overloaded operator, and then on the right-hand side, we've put v1 there, and then that will call the overloaded operator method and pass in the reference v1, and then it times the x and y values, which are positive 10 and 15, it times them by -1 to result in -10 and 15, and then passes them back, and then back in main, we assign those values to v2, and then output them as a cout statement below there. And here, in another example, we've set up a enumerate type called day, which represents the days of the week. And the enumerate types are assigned an integer value, ranging from 0 to n-1. But whilst they have integer keys, they're not recognized as integer values. So the ++ operator doesn't actually work with it natively. However, we can overload the ++ operator so that it does work with enumerate types. And here's the solution, where we've defined a method for our overloaded operator, following the same format as before. But notice in main, we've actually used the prefix version of the ++ operator. And there's an important distinction here between prefix and postfix. If we wanted to use the postfix version of the increment operator, we'd have to set up another integer in the arguments list for the overloaded method. It's referred to as a dummy parameter, which can be inserted to act as the right-hand side of the operator, meaning that the reference to the object is then treated as the left-hand side, which brings us nicely onto binary operators, which do indeed have a left and a right-hand side to the operator. And to demonstrate this, we're going to revisit the vector example, which we looked at earlier, and modify it so that we can add vectors together with a plus sign. So in main, you'll notice that we've declared two vectors with x and y coordinates, and then we're going to add them together using the overloaded operator method. which, if you pay attention to the parameter list, we're actually passing in the references to these objects as constant references. Notice the keyword const there, both with the left and the right reference. And we're doing this just so we don't accidentally modify the values of those vectors, because instead we want to add them together and then return them and assign those summed x and y coordinates and assign them to a new vector, which is v3 in the main. It's also worth noting that we can overload the comparison operator, which of course has a left-hand value and a right-hand value. And this method's going to play an important part in this course because we're frequently going to have to search through data structures full of objects and then have to compare our object with another object to see if it has the same value. So this is an important principle to remember going forward. And finally, the last thing to mention is that when you're overloading your operators within a class, you can make use of the this keyword, which is going to act as a reference to the object on the left-hand side of the operator, meaning that you can remove the reference to the object on the left-hand side from both the unary operators and the binary operators. So you can see here that the unary operator no longer takes any arguments in the parameter list, whereas the binary operator only takes a reference to the object on the right-hand side of the operator. Okay, so let's have a go at applying this in our first exercise then, and I'll show you how to get started. Okay, so for the first exercise here of week 1, operator overloading, I've got the exercises on the left-hand side here, and I've got a new project set up here. I've titled mine according to the week number and the topic, but of course you can choose your own names, that's not a problem. And our first exercise is to create an entity class and then have a go at overloading these operators. So let's add the entity class first. Let's go to project and add class. Let's say entity there. All right, and I've been given the class definition. It's a fairly simple one. We've just got one attribute, which is integer size variable, and we've got a constructor, which just initializes the value of size by the parameter passed in. Okay, so I'm going to copy and paste that over the template which was created for me, so that now we've got the class definition here. And let's have a go at overloading the first operator that we're specified here, the increment operator, ++. So if you remember the format, the signature, so with this particular operator, we're going to be returning an entity object. So let's type entity as our return type. And then we write the keyword operator, followed by the operator itself, so ++. And say if we wanted to add the implementation within the header file, we'd add the braces, of course. And then within here, we just want to increment the value of size for each entity. So when we write in the main, when we come to write with prefix, we'd write ++ entity object. It's within here that we then want to increment the size value. So, and if you remember, we don't actually need to have a reference to the entity object here because we can get to it via the keyword this. So we can write this arrow link size to get access to the size variable. And then if we're doing prefix, we'd of course put the ++ before that. And there's numerous ways you can do this. You could assign that incremented value to a temporary integer variable and then return that temporary variable wrapped up within a entity object or a call to the constructor. So I could actually pass temp here, and that would return the entity object with that new value. Or if you want to, a more efficient way, you could actually replace that line with the incrementation within there directly. Okay, so let's just check this works, and I'm going to need to include entity. So let's do that, and let's create an object of the entity class. So let's say en1, and let's give it a value of say 10, just to start with. And then if we say plus plus en1, so we're attempting to increment our objects, entity objects. Let's see if we print out the value of that size, en.size, what we get. Yep, and notice we incremented from 10 to 11. Okay, that's good. So that's the implementation in the header file. If you wanted to work within the CPP file, let's load that up. I'm going to copy this and paste it within the CPP. And then remember the particular formats is we have the scope resolution operator in between our class name and the particular method name in this case, but then we also want to return an entity object. Okay, and what I'm going to need to do is remove the implementation from here. And there we go. Okay, so let's just save everything and double check this works. And yes, there we go. Okay, so now that we've had a go at the increment operator, have a go for yourselves then and see if you can create overloaded operators for the prefix, the less than and greater than. But remember, these will be binary operators because they take both a left hand and a right hand value. Okay, so give it a go and see how you get on. So now that we've had a look at operator overloading, let's move on and have a look at the vector. And a vector data structure is considered to be an alternative to an array. And like an array, vectors store their data in separate elements, and these elements are also indexed, so we can access a particular element via the index number if we know it. But unlike an array, a vector has the capacity to grow and contract as required. You can easily add an element onto the end of a vector, which you can't do with a fixed size than array. Okay, so when it comes to implementing a vector, we have to include the vector library, which is an include statement at the top. And then we have to specify the type of data that's going to be stored in this vector. It's still a strongly typed data structure, so we can't store mixtures of types in there. We have to store one type only. And then we can set an optional size. And then optionally, we can set the size of the data structure, the number of elements that we want to start with. And we could even assign an initial value if we wanted to for these elements as well. But as we said in the previous previously, of course, we can expand and contract this data structure as required. And like an array, we can also access the elements via the subscript operator, which are the two square brackets. So we can assign and also access data stored on our vector through that operator. But we can also add items to our vector via the pushback method, which will add the item to the next available index, even if we don't know what that index is. And this is an example of an advantage that the vector has over the array, because the vector is bundled as a template class in C++, whereas the array isn't. So therefore, if we're using a vector, we can take advantage of the different methods and attributes that come with it. And as well as traversing through the vector via the index, for looping through each element of the vector, we can also traverse the vector by making use of the iterator structure. And this iterator contains pointers which point towards the start of the structure and the end of the structure. And rather handily, the vector class contains two methods which return the starting location and the ending location of the vector as pointers. So we can integrate this iterator structure with our vector, where we set the pointers to begin and end, and then we just iterate by incrementing that pointer, which, if you're familiar with pointer arithmetic, means that we change the address that it points at by incrementing the pointer. And then we can also integrate other methods which belong to the algorithms library, which can be included via the include statement at the top as well. So we can also perform other operations on our vector, such as find, copy, sort, and also locate the minimum value and the maximum value as well. We can use the find method from the algorithms library to search through the vector and return the matching value if it finds it. And also, it can return an iterator so that you can search through the remainder of the list from the value, the element, in which was found. So this would be really helpful for trying to locate duplicates that are later on in the list. However, if we have a vector of objects of classes that we've made, or user-defined types, we're required to overload the equality operator when using the find method. So we're going to have to revisit the operator overloading, which we had a look at in the previous video, and we're going to have to apply it here with the equality operator. And within that overloaded method, we can make use of the iterator, as remember it's a pointer. So it will point to the current object that's being looked at in the vector, and then through that reference, we can get access to the data, and then compare that data with the particular value that we're looking for. So that's a handy way of making the find method work with vectors of user-defined types. And the final method that we're going to take a look at from the algorithms class is the arrays method, which can be used to erase either a single element of a vector, or we can specify a range of elements that we want to delete from the vector. And this method's typically used in combination with the find method. So we have to find the value we want to erase first, and then we pass that iterator to the erase method, which then invalidates that iterator and removes the values from the list. And rather conveniently, the vector will automatically reposition the elements that were removed, meaning that the vector never uses more memory than it needs to for storing the values which are in the list. And let's put this all together to have a look at an example just before we start our exercises. And so here in this example, we've set up a vector to store integers, and we've called the vector data. And then we're going to use the pushback method to assign the values of our loop counter, which is called n, which ranges from 0 to 14. We're going to assign them to the elements of the vector. And then underneath the for loop, we've set up an iterator, which will take on a pointer to the beginning element of the vector and then the final element of the vector. And then we're going to increment that pointer to then print out the values within the vector. And then in the next lines, we're going to be attempting to find the value 6 by passing that to the find method. And then if that particular value exists, we just print it out that we've found that value. Okay, so this is just a full example of how we could use a vector. Okay, so let's have a look at the next exercises then, where we're going to be applying this and writing vectors of our own, and I'll get you started. Right, so let's have a go at exercise 2 then, and let's implement a vector. So the first thing we're going to have to do is create the weapon class, because we're going to create a vector that holds weapon objects. So I'm going to add a new header file for that. Let's call it weapon. And I've been given the class definition, so I'm going to copy that there into here. Save that. And now if I go back to main, I'm instructed to create a vector of these weapon objects. So I'm going to have to include a few things here. I'm going to have to include the weapon class itself, weapon.h. I'm also going to need to include the vector class as well. And just for good measure, let's also include the algorithms class too, because we're definitely going to need that later on. Okay, so let's create a vector. So we type the word vector and have to specify the type of data that we're going to store there. So as we're storing weapon objects, we would need to write weapon, the class name, within the angle brackets. And then we just need an identifier for our vector after that, like the object name, variable name. So I'm going to call mine data. And next, I'm instructed to create 10 weapon objects using the pushback. So let's set up a pushback method, that is. Let's set up a for loop, because I know how many times I want to increment. Standard for loop, let's start at 0 and then increment whilst less than 10. And then I want to call the pushback method of the vector object, which is data. And it's also here that I'm going to have to create a new object of the weapon class. So I'm going to write weapon there. And then within the call to the constructor, I'll pass the loop counter to assign a unique ID ranging from 0 to 9. That's the most practical way to do that, because that will not only instantiate a new object of the weapon class, but also give me a unique ID for each one of them. Okay, so that should give me my 10 weapon objects assigned to each element of the vector. Next, I want to define an iterator to iterate through the vector, printing out the values. So remember the syntax here. I need to specify an iterator, but I need to specify that it is of the vector. So I would write the similar syntax. I would write vector, weapon, and then scope resolution operator, and then keyword iterator, followed by a object name. Okay, so it's that syntax we want to follow. And then remember that the vector class has pointers to both the starting element and the end element, called begin and end. So I can actually loop between those two elements. So if I was to create another for loop, I could start by assigning the begin pointer to it. So let's say data.begin there. Oh, that's a 0. And then I can repeat whilst we're not at the end pointer. Okay. And then finally, I just want to increment it. Okay, so it follows a very similar format to I above, but I'm just replacing 0 and 10 with data.end and data.begin. Okay. And then within here, all I have to do is just print out the IDs. And of course, I can get to those IDs via the iterator pointer. Okay, because all I'm doing is I'm incrementing the pointer each time. Okay, so let's check this. Yeah, and there you go. You can see the IDs printed there from 0 to 9. Okay, so have a go then at exercise 3, where we have to delete a weapon object from within the vector. And to do that, we also need to overload the equality operator. Okay, so give that a go and see how you get on. So now that we've had a go at implementing vectors, let's move on and have a look at recursion. And recursion is quite an elegant solution for certain programming issues, and it can also be used to solve other mathematical equations such as Fibonacci sequences, powers of numbers, as well as factorials as well, where you can return the appropriate numbers. And it can also be used to navigate a variety of data structures as well. We're going to be applying it to trees in the future when we navigate through those. It's a rather elegant solution, but not necessarily the most efficient solution, it should be said. It is actually quite costly in repeating the same processes multiple times. However, there is a technique called memoization, which can be used to speed this up, where you actually store the previous method calls so that you don't have to keep repeating them from scratch. Okay, I'll link you to a video on memoization so you can have a look at that. Okay, but back to recursion. Essentially, recursion is a method which calls itself. At some point within a method, there will either be an explicit call, perhaps within an if statement or a particular case, to that method, or there might be a return statement at the end of the method, which indeed does call the very same method. Perhaps it passes something to the method that was calculated from within it. It needs to update a particular number, perhaps. And this allows a continuous loop, if you like, where a method continues to call itself. And this is called the recursive case. Okay? But eventually, to prevent an infinite loop, there will have to be an end case, which we call the base case. And this is where the method is no longer going to be called. So eventually the method will have to terminate without calling the method to prevent a stack overflow. You may remember back to the previous module where we attempted to overload the stack, and if you remember, we continued to call certain methods and added up numbers, and eventually that ran out of memory. So that's just something to bear in mind when you're writing your recursive methods, that you must have a base case where the method will eventually stop calling itself recursively. Okay, so let's have a look at an example. Okay, so in this example, you'll see that we have a method called DisplayLessThan, which is kept within the numbers class. And then within main, we're going to create an object of this class and then call this method DisplayLessThan passing 20. So the first time we call this method, we pass 20 in, and then the next line in the method is decrementing n, so it goes to 19. And then the next step is to compare n and see if it's greater than 0, which it is, and 19 is greater than 0. So then we call DisplayLessThan, passing it the new value of n. Okay, so we actually go right back to the top of the method and then start again. So, and then we decrement n, okay, and then it goes to 18, and then the if statement, 18 is greater than 0, so we call DisplayLessThan again, passing it 18 this time. And then we repeat again, okay? And the interesting thing here is that we're not outputting the numbers until we get to 0. Because you notice that the cout statement is actually underneath all of these recursive method calls. So we're actually loading up the stack with all of these method calls, which once n does reach 0, and we no longer have to add another method call to the stack, we then go back down the stack and essentially output all of the values that have been stacked up. And that's why we get 0 to 19 rather than 19 counting down to 0, which is an interesting distinction there, based upon where you place the output. Okay, because if you'd have put the output above the recursive call, you would have printed them out in descending order, starting from 19 going down to 0. So these are things to bear in mind when you're writing your recursive statements. So from here, let's have a look at some of the exercises. And in these exercises, we're instructed to write recursive methods for working out the factorial of a number, and then also have a look at an iterative solution as well. Okay, so I'll get you started on that. Okay, so let's implement exercise 4, which looks at recursion. So the first thing we're instructed to do is to define a class for the IOObject. So let's do that. Okay, we want capitals for IO and then capital O for start of object, and then lowercase after that. So IOObject stands for in-out object. And within that, we're given a method to use. This is actually the same method we looked at in the previous video, the recursive solution for displaying numbers less than. And just before I add that in, I've got to define the structure of the class. So I'm just going to do that. And then now I can copy in this DisplayLessThan method. So let's do that. And as I'm going to be printing data to the screen, I'm going to need to include IOStream. And using no space. std. All right, so let's resolve that. And let's go back to main, because I'm going to need to include it here as well. I'm going to need to include the header file for IOObject. And then within main, I'm instructed to create an instance of IO and invoke the method DisplayLessThan passing 20. So let's do that. So let's create an object of IOObjects. Let's call it IO. And then through IOObject, we will call DisplayLessThan passing 20. And so, I mean, from doing the from looking at this code in the previous video, we should already know that it prints out values from 0 to 19. And if you did want to step it through, it might be a useful way just to see how it works. You can add in the breakpoints there, and at various points, so you can then step it through and look at what the values are and how it calls itself again. But just to save time, I'm going to move on and have a look at the next part of the exercise, which is we're given the code for the factorial to work out the factorial of a number, and here we're actually given the iterative solution for this. So I'm going to copy the code into this, and this is another method. And remember that the factorial is going to be subtracting 1 from that number every time, multiplying it by itself. So the factorial of 4 is going to be 4 times 3 times 2 times 1. Okay, so here we're instructed to copy the iterative factorial method, and let's invoke that from main just to check that works as expected. So if we pass 4, that should be 4 times 3 times 2 times 1, giving us 24. And as this is returning a value, I'm just going to print that to screen. Let's run that. Check it works. Yeah, there you go. There's 24 printed underneath the previous method, the DisplayLessThan here. And there we go. That is that exercise. In the final exercise, you're asked to modify this factorial code, the iterative solution to it, to make it a recursive solution. Okay, so I suggest studying this DisplayLessThan method, and then creating a new method for, you could call it FactorialR, as indicated, and then implement recursion here so that you perform the same solution, you get the same end result, 24, but with recursion. Okay, so give that a go.